A planet 25 million miles away has been keeping its secrets under a thick layer of acid clouds throughout 60 years of scientific research. And no one suspected that a world that for 30 years we had concluded was dead could still be erupting, breathing, living, and the answer had already been sitting on 32-year-old CDs in a warehouse in California, waiting for a man to sit down for 200 hours to find it. Stay, because I am about to take you through what scientists have just confirmed about Venus, Earth's sister planet. And hit subscribe right now, because this channel analyzes real space discoveries without the hype, and you do not want to miss what else is emerging from the solar system. Let us go back to the beginning. For centuries, Venus, the closest planet to Earth in the entire solar system, had hidden its secrets beneath a layer of clouds. Not water clouds like on Earth, but thick sulfuric acid clouds, tens of kilometers high, wrapping the planet without a single gap. Optical telescopes, the ones that let us see the surface of Mars, the moons of Jupiter, the cloud bands of Saturn, were completely useless here. Visible light could not penetrate that acid cloud layer. Humans could map the moon in detail down to individual craters, but for the nearest planet to us, we only saw a pale yellow sphere. Absolute mystery. Then in the early 1990s, a spacecraft named Magellan entered orbit around Venus. The mission was simple and modest. Fire radar down at the surface, map most of the planet, collect some measurements, then drift into the atmosphere and burn up. Expected lifespan, 2 years, maybe 3 if lucky. What actually happened was one of the most extraordinary achievements in the history of planetary science, and most people today do not even know it occurred. Magellan did not die on schedule. It entered a near-polar elliptical orbit, flying from north to south, each revolution 3 hours and 15 minutes. And each of those revolutions, as Venus rotated a little beneath it, Magellan painted another new slice onto the enormous map being built. After 3 cycles, by September of 1992, Magellan had imaged 98% of Venus's surface, at a resolution of 100 to 250 meters per pixel. Then something happened that suddenly made the entire story much larger. 98%. No other planet in the solar system besides Earth had ever been mapped in that much detail. Not Mars, not Mercury, only Earth and Venus. Magellan was the first spacecraft in human history to look through that acid cloud layer and map all of Venus. Not a portion. Not one hemisphere, all of it. And Venus, it turned out, was nothing like what scientists had predicted. On Magellan's maps, more than 80,000 volcanic structures appeared. 85% of the surface was lava flows. There were giant shield volcanoes named Maat Mons and Maat Mons. Maat Mons nearly as high as Mount Everest. But there were only 940 impact craters on a surface 3/4 the size of Earth's. The Moon has hundreds of thousands, Mars has tens of thousands, while Venus has only 940, scattered almost at random. As if the entire planetary surface had been wiped clean all at once, only a few 100 million years ago. Scientists named that hypothesis catastrophic resurfacing. About 300 million years ago, a massive geological event flooded the entire surface of Venus with lava, covering everything that had been there before, then went quiet. And since then, Venus had been silent, a dead planet. That was the standard model for 30 years. But by 1994, Magellan had to end. The spacecraft had completed 3 radar imaging cycles and 3 gravity measurement cycles. Fuel was nearly gone. The electronics were beginning to fail after 4 years of exposure to solar radiation twice as intense as at Earth's distance. The craft had been launched by the Space Shuttle Atlantis on May 4th of 1989, the first interplanetary spacecraft in history launched from a space shuttle, and now it had reached the end. On October 13th of 1994, engineers at the Jet Propulsion Laboratory made a ruthless but necessary decision. They commanded Magellan to lower its altitude and plunge into Venus's atmosphere, an atmosphere of 96% carbon dioxide, 467 degrees Celsius at the surface, hot enough to melt lead. The spacecraft, weighing only about 1,350 kilograms, was used for one final experiment. While burning up in the acid atmosphere, its sensors sent back to Earth the last data on air density, temperature, and atmospheric dynamics before individual components heated to the melting point and stopped functioning. There was no final signal, no goodbye, only sudden silence. Magellan was dead, but at the same time, in laboratories across the United States, the CDs containing its radar data had piled up in locked cabinets. 4 years of data, 150 gigabytes, spread across thousands of disks. Robert Herrick, then still a young scientist, later recalled, "We received boxes of CDs mailed from NASA, carefully packed, and we stored them in the research lab's lockers." Nothing was more inconvenient than trying to analyze a dataset like that in the 1990s. Computers were not powerful enough, software was not sophisticated enough, and scientists at the time had too much other data to process: impact craters, mountain ranges, coronia, atmospheric models. No one had the tools to sit and compare every image with itself at a different time at full resolution. From the early 2000s, a few scientists had begun reprocessing the old raw data from the Soviet Venera missions, using modern computers to filter signal noise that 1980s mainframes could not handle. But no one had truly touched Magellan at a scale sufficient to find anything. So the CDs went into the cabinets, the cabinet doors were locked, and an entire planet waited 30 years. Picture that. 200 hours. If you work 8 hours a day, that is 25 consecutive days. If you work 4 hours a day, that is 50 days. That is 2 months of one man's life, sitting in front of a computer screen, comparing gray images of a planet no one had actually visited in 3 decades. There was no guarantee he would find anything. There was no guarantee he was not wasting his time. There was no guarantee he was not fooling himself out of a desire to find something. This was not work for a scientist seeking quick fame, because if you want fame fast, you do not dig through 30-year-old data that everyone has already concluded was fully mined. This was work for someone with the patience of a person who believed something was there and was willing to sit quietly long enough to find it. While Herrick sat in his office at the University of Alaska Fairbanks comparing those images, computers around the world were running trillions of calculations every second. Thousands of AI systems were analyzing scientific data. Dozens of spacecraft were orbiting Mars and the Moon. But the biggest discovery about Venus in 30 years did not come from automation. It came from the eyes of one man. Herrick began that work because NASA had announced a new mission called Veritas that would return to Venus for the first time in 30 years, and he had been selected for the science team. And he had a thought that no one before had fully carried out. If Veritas was going to Venus to look for active volcanoes, then perhaps the traces were already in the old Magellan data, just waiting for someone willing to sit down and look carefully. He also admitted clearly, only in about the last 10 years had Magellan data become accessible at full resolution on personal computers. Before that, even those who wanted to analyze it did not have tools powerful enough, but he said straight that he did not really expect success. Yet he still sat down. He chose Atla Regio, a highland near Venus's equator containing the 2 large volcanoes Mons and Maat Mons. This region had long been suspected of still being active. Venus Express had detected SO2 anomalies and emissivity, but there had been no direct evidence. He began comparing the February 1991 image from Cycle 1 with the October image of the same year from Cycle 2. The same patch of surface 8 months apart. He found nothing on the first day, nothing in the first week. He switched regions, went back, tried many different combinations of viewing angles. Imagine that moment, late afternoon in Fairbanks, Alaska, winter coming early, the sun already set by 3 in the afternoon. Outside the office window, snow was falling on the empty streets of the university campus. Inside, a man sat in front of 2 computer monitors. On the left screen, the radar image taken in February of 1991 zoomed so each pixel was the size of a grain of rice. On the right screen, the same region, taken in October of 1991, 8 months apart. He had looked at these 2 images dozens of times over the past week, and suddenly he saw it. A volcanic vent in the upper right corner. In the left image, it was round, small, neat, less than 2.2 square kilometers, steep inner walls, with traces of lava flowing down the outer slopes. It looked like a vent that had only recently stopped being active, but in the right image, that same vent had become irregular. Its area had doubled, the walls had lowered, nearly filled to the rim. He blinked, he zoomed in, he compared every feature. Not an illusion, not a different viewing angle, not a metadata error. This was the same point on Venus, imaged the same way, 8 months apart, and it had changed. That vent lay on the northern flank of a shield volcano in the Maat Mons system, the mountain nearly as high as Mount Everest that Magellan had mapped 30 years earlier. The change meant a major geological event had occurred here, in those exact 8 months, enough to double the vent's size, collapse the walls, and fill the interior, possibly with lava still molten when Magellan flew overhead. He sat in silence. He did not move, did not write notes, did not call anyone, just looked. Because if what he was seeing was real, then 30 years of scientific models of Venus had just changed. 30 years of textbooks had just needed to be rewritten. 30 years of consensus that Venus was dead had just collapsed in a single moment in the upper right corner of an image taken in 1991 that no one had truly seen until today. His first feeling was not excitement, it was skepticism. Herrick contacted Scott Hensley at JPL, the leading radar expert, who had been on the original Magellan science team. Over the following months, they ran model after model, testing every non-volcanic scenario, landslides, Venus quakes, collapse from seismic shaking, the same kind of explanations used for Aphrodite Terra 30 years earlier, only an eruption fit. On March 15th of 2023, the results were published in the journal Science, the first direct geological evidence in history of active volcanism on Venus. Not indirect speculation, not theoretical models, direct evidence. A young team at the University of D'Annunzio in Pescara, Davide Sulcanese, Giuseppe Mitri, Marco Mastro Giuseppe, decided to do what Herrick had done but on a larger scale, not comparing individual images to find changes in vent shape, but comparing radar signal intensity, what is called backscatter, over wide areas, between different Magellan cycles. The principle was simple. If new lava had been erupted somewhere on Venus's surface in the period between cycle 1 and cycle 2, then the new rock surface would reflect radar differently from the old rock surface. The backscatter intensity would change, and they found that 2 sites. The first was Sif Mons, a shield volcano in the Isla Regio region. On its western flank, backscatter intensity had increased significantly between the 1990 and 1992 observations. It could be new lava that had spread and solidified into a new rock layer. The second site was western Niobe Planitia, a vast lowland plain scattered with volcanic structures. There, the same kind of backscatter change also appeared. The Italian team spent many months ruling out every other explanation. Could these be microdunes formed by Venusian winds? No, the terrain did not match. Could this be atmospheric effects interfering with the radar? No, other observations from the same period showed no interference. Could this be differences in viewing angle between the cycles? This was the hardest question, and they spent months ruling it out with detailed models. Conclusion: the most likely explanation was that new lava had been erupted in the time between the 2 cycles, and when they calculated the possible lava volumes, the numbers shocked the entire scientific community. Sif Mons, maximum flow of 25.2 cubic kilometers per year. Niobe Planitia, maximum of 37.8 cubic kilometers per year. In total, the maximum eruption rate for these 2 sites equaled, or even exceeded, Earth's average eruption rate over the past 180 million years, estimated at 26 to 34 cubic kilometers per year. The results were published in Nature Astronomy on May 27th of 2024. Venus, it turned out, was not only still active, it may be as active as, or even more active than, Earth, a planet that for 30 years we had called dead. But the story of science is never a straight line, and this is where it becomes strangest. On April 22nd of 2026, the journal Nature Astronomy published a rebuttal paper, titled Challenges in Detecting Active Volcanoes on Venus. Lead author was Gerard Garado I Paris at Imperial College London. The co-authors included Birivarasu, Brossier, Diancheco, Campbell, and, this is the detail no one expected, Scott Hensley. Yes, the very scientist who had co-published the Maat Mons discovery with Herrick in 2023. The very person who had stood before the world and said there was direct evidence that Venus was still active. Now, he was a co-author of a paper arguing that Sulcanese's evidence, the discovery that came after his own, might not be as claimed. Gallardo argued that the backscatter changes Sulcanese observed could be fully consistent with differences in radar viewing angle between Magellan cycles. No eruption was needed to explain them. Just a slight difference in radar geometry was enough. In the geological context of those regions, he argued that new flows made little sense. Better change detection frameworks were needed. Better topographic data were needed. Clearer morphological evidence was needed. This was not a personal battle. Gallardo and Hensley carefully emphasized that they were not opposing the idea that Venus is still active. Gallardo said, "We agree that Venus is very likely still geologically alive. We are only saying that the radar evidence published in their study is not conclusive." But the unspoken message was clear. The second pillar, Sulcanese, Sif Mons, Niobe Planitia, was being questioned by the very person who had erected the first pillar. And in the middle of that scientific dispute, the community realized a painful truth. We cannot settle this question with the old Magellan data. It has been 32 years since that spacecraft burned up. Its data have been squeezed to the limits of what can be concluded with certainty. To know for sure, we need a new spacecraft. We need new eyes. We need to return to Venus. And 4 spacecraft are preparing to do exactly that. The first and earliest is Shukrayan-1 of the Indian Space Research Organization, ISRO. The Indian cabinet approved it on September 18th of 2024. Launch schedule, March 29th of 2028, on an LVM-3 rocket from Sriharikota. Arrival in Venus orbit on July 19th of 2028, exactly 112 days after launch. 34 years after Magellan burned up. Shukrayan carries 2 types of radar. VSAR, Venus Synthetic Aperture Radar, has 4 times the resolution of Magellan. If there have been new eruptions on Sif Mons or Niobe Planitia in the past 32 years, VSAR will see them. And for the first time in the history of Venus exploration, a spacecraft will carry ground-penetrating radar capable of looking a few hundred meters beneath the surface to measure the geological layers below. This technology could confirm or refute the new lava layers that Sulcanese proposed exist. Next is NASA's Da Vinci Plus. expected to launch in the late 2020s to early 30. The spacecraft will make 2 flybys of Venus before releasing a descent probe through the atmosphere. The descent probe lasts 1 hour, analyzing atmospheric composition, chemistry, and the water history of Venus. It is not expected to survive to the surface, but the data on the way down are invaluable. Then NASA's Veritas, expected to launch in June of 2031. The VSR radar has 10 times the resolution of Magellan. VM, Venus Emissivity Mapper, built by the German space agency DLR, can search for hotspots on Venus's surface, direct traces of active lava lakes. And finally, Envision of the European Space Agency, also launching in 2031 on an Ariane 6 rocket from French Guiana. Envision carries dual polarization VENSAR, a suite of 3 Venspec spectrometers to search for volcanic gases in the atmosphere, and a radar sounder that can measure subsurface structure hundreds of meters deep. All 4 spacecraft will be operating at Venus in the early 2030s. Beyond NASA and ESA, Russia, China, and a private American venture called Venus Lifefinder also have their own plans. For the first time in 30 years, the entire global space community is turning toward the sister planet. Robert Herrick, a professor in Alaska, the man who reopened the Magellan data over 200 hours, is a science team member of both Veritas and Envision. He will watch with his own eyes as Shukrayan's VSAR images Maat Mons first, Veritas's VSAR images hit a few years later, and Envision's VENSAR provides the final confirmation. He has spent 30 years of his career looking at Venus with no one going there. He only needs to wait 2 more years, 2 years to know whether his eyes were right. Now let us return to what started it all. Let us return to the warehouse in Southern California, where those 32-year-old CDs still lie silent in the dark. Because this is the most thought-provoking part of the entire story. Magellan is dead. It burned up in Venus's acid atmosphere on October 13th of 1994. No debris remains, no memorial signal, only sudden silence. But the data it sent back to Earth before dying are still here, 32 years later. And every few years, a scientist reopens that data, and Venus tells us something new. In 2023, Herrick found a volcanic vent that had changed shape. In 2024, Volcanism found 2 regions of new lava. In 2025, Cascioli found 52 living coronae. And perhaps right now, as you watch this video, another scientist is sitting in front of a screen, comparing a new region of the Magellan map that no one has paid attention to. Perhaps they are about to find something. Perhaps that will rewrite yet another page of the textbooks. Because Magellan completed its mission in 1992, but it is not finished with its work. It is still working. 32 years after burning up. From inside the CDs in a dark warehouse, from inside the digital data streams that no one had read for 3 decades. And the question about Venus does not stop at geology. In 2020, the James Clerk Maxwell telescope detected phosphine in the upper atmosphere of Venus. On Earth, phosphine is produced by bacteria in oxygen-poor environments. In 2022, NASA pushed back. It might be an analysis error. But in 2023, Professor Jane Greaves of Cardiff University announced that JCMT had redetected phosphine, this time deeper in the atmosphere. No one knows for certain. But if true, the question about Venus is not only whether it is geologically dead or alive, it is also whether there is any life there. Earth's sister planet, it turns out, is not a dead planet. It is a living planet, active, changing, erupting, but in a state where we cannot live. It took the path that Earth did not take, and no one is certain why. No one is certain whether Earth is safe from that path. No one is certain how long the habitable window on an Earth-like planet lasts. There are questions that can only be answered by looking at our sister planet, not by theory, not by mathematical models, by direct observation, by flying there and looking. And for the past 30 years, we have had nothing to look at except 30-year-old data from a dead spacecraft. 3 pillars have risen. 1 pillar is wobbling, and the central question remains unresolved. 2 hypotheses are competing, and no one can choose between them until the new spacecraft arrive. Hypothesis 1, Venus is truly as volcanically active as Earth. If true, the catastrophic resurfacing model of the past 30 years is dead. There is no 300 million year cycle of silence followed by catastrophic renewal, only continuous, prolonged geologic activity that never stopped. Venus is not a fossil, it never died. Hypothesis 2, Herrick is right, but Volcanism is wrong. Venus is active, but only at a few local hotspots, Maat Mons, perhaps Mons, perhaps a few of the coronae Cascioli found. Not global, not Earth level. The old model only needs a few exceptions added. And behind those 2 hypotheses is the larger question that no one has answered in 60 years. Why did Venus diverge while Earth did not? Because of size? No. The 2 planets are nearly equal. Because of distance from the Sun? Possibly Venus is 30% closer. Because of the timing of magnetic field loss? Unclear. Because Venus has a stagnant lid while Earth has plate tectonics? That is the present, but is that the cause, or only the consequence? No one has the answer. No old Magellan data can provide the answer. There is only one way to know. There is only one way to settle the debate that began in 2023 and is still unresolved in 2026. Only new spacecraft, and 4 spacecraft are coming. But whatever the result, one thing is already certain. There was a machine launched by the Space Shuttle Atlantis on a May morning in 1989. It flew to Venus. It mapped 98% of that planet's surface. It burned up in the atmosphere in October of 1994. And 30 years later, when all the scientists who built careers on its data have retired or passed away, the CDs pressed that year are still speaking. They are still changing how we understand the sister planet. They will still be speaking when the next generation grows up and walks into the laboratories. Perhaps one of you watching this video, perhaps your eyes will be the next ones to reopen a region of the map that no one has noticed. Perhaps you will find something more. Because the machine is dead. But the signal is still arriving. Not by radio waves, not from deep space, but from inside 32-year-old CDs in a warehouse in California. From inside 200 quiet hours in front of a computer screen in Alaska. From inside the patience of a person who believed something was there and was willing to sit long enough to find it. The signal is still there, on the disks, in the warehouse, waiting for the next patient person. The question is anyone paying attention? If this kind of story is what you came here to find, subscribe now and turn on notifications. Leave a comment with what surprised you most in this video. And share it with someone who needs to hear it. Because this story deserves more than the silence it is receiving.